Clayton, the Algebra Guy here, and as you see on your screen, today's lesson is how to add and subtract polynomials, a very fundamental skill that you're going to need as you go through algebra. So let's jump to it. Our TEK that we're covering today is A10A, which says adding and subtracting polynomials of degree 1 and 2. That simply means exponents that are 1 and 2. So we're not going to go beyond that today for the most part. In particular, we're going to be identifying polynomials, monomials, trinomials, binomials, making sure we understand the difference between those, adding and subtracting monomials and polynomials, and then we're actually not going to evaluate polynomial. All right, so let's jump right to it. All right, so our first thing we want to cover is to review a little bit before we get into some vocabulary and terminology. You've learned that a term is a constant or a product of a constant and one or more variables. What do I mean? So it's a lot of words there. So let me give you some examples here in just a second. Let's start with this idea of a constant. So just some number, right? So just some constant, 3, or the product of some constant. So we have some constant here multiplied by something right here. Both of these are considered terms. So I just want to remind you what a term is. These are considered terms. 4xy is still a term. All these are being multiplied to receive a product. Now, when it's in the form ax to the m, where a is a constant and m is a whole number, it is called a monomial. So what do you mean in that form? Well, let's look at some examples. So all of these are considered monomials. How is that? So this 8 is a monomial, negative 2x squared, 4y to the third, 11z to the 7th. How are these monomials? How are they in this same form? Well, how is 8, first of all? That looks kind of strange to be in this form. Well, 8 is the constant, and then x, and actually this would be to the 0 power. Because over exponents, when we discuss exponents, we see that anything to the 0 power is 1. So 8 times 1 is still going to be 8. So you could think of this one in that structure. So we're still talking about monomials, or in this case, this is just a monomial. So these are some examples of monomials, and I'll give you some more here as we move forward. Now, what is a polynomial? So a polynomial is a monomial of two or more monomials combined by addition or subtraction. These are polynomials. So here's some definitions here. Monomial, as you can imagine, mono means one. A polynomial with exactly one term is called a monomial. Binomial, like biceps, there's 2 muscle heads, bicycle, 2 wheels. You're familiar with bi. A polynomial with exactly 2 terms is called a binomial. A trinomial obviously has 3 terms. So we're going to look at some more examples of that here right now. So monomial, here's some examples of monomials. Notice that it's just that term and it's not separated by any addition and subtraction. Now, as soon as we introduce addition and subtraction in between terms, now we have different terms, because notice that a and 7 are completely different. They don't share an exponent at all. I'm sorry, they don't share a variable at all. So this is completely 2 different. Now, if they were a and 7a, then we'll just combine those and make one term. But these are 2 different terms, so those are binomials. Trinomials obviously have these 2 plus or minus 2 operations of addition and subtraction between the 2. So you have 3 different terms, and polynomials could be any of those, right? So it could be up to 4 or 5 and so on. So just some basics before we get started. Let's practice that, make sure you got it, understanding how to identify monomial, binomial, trinomial. So let's look at this one here. We see that we have 4y squared minus 8y minus 6. Which one is this one? Now I want you to answer this to yourself on your paper before I do it, because it's the best practice. So which one are you saying this one is? I'm hoping that you just said that this was a trinomial, right? Trinomial. And I'm probably not going to write out all these. This is this trinomial. So there's 3 different terms. What about this one? I'm hoping, did you say monomial? Monomial? Because there's no addition and subtraction. Now this negative sign attached here makes it look like it is, but it's actually not adding or subtracting to anything else. This is just one term because this is a product of some things being multiplied together. Now in this one we do have, right, so some subtraction signs, so I know we probably have more than one term. Why do I say probably? Because we got to make sure that the variables are different, and they are. X to the 5th, x to the 3rd, x squared, x. So these are all completely different. We got 1, 2, 3, 4, 5, literally 5 different terms here. So it's not going to fit monomial, binomial, or trinomial. So we're just going to call this a polynomial. I'm just going to abbreviate just poly here. And for D, we have just subtraction. So this is a binomial. And lastly here, this is a monomial. There's nothing else with that one. So hopefully you got that right. Let's move forward as we continue this. All right, you've learned how to simplify expression by combining like terms. How do you do that with addition and subtraction? So remember, like terms must have the same variables with the same exponent. If monomials are like terms, we just combine them by adding and subtracting the coefficient. So what is the coefficient? Before I even start to work this, you probably remember, right? So let's write this out right here. 3x plus 4x, something really basic. What is the coefficient? Well, the coefficient is just going to be that number right in front of our variable. Those we call coefficients. So this just a reminder here, and these are my coefficients. This right here, these two are my coefficients. So let's start with this really basic problem. We have a variable of y squared. They're both the same. And since they're both exactly the same, we can call these like terms, right? These are like terms. And when I have like terms, I can go ahead, in this case, it's calling me to add my coefficients, 25 plus 15. Well, 25 and plus 15, when you add those, gives you 40. So now you can just say 40y squared. Notice I keep my variable the same. It's just like saying I have 25 pencils and 15 pencils. And if I add them all together, I have 40 pencils. There's no need in changing the variable. We just added them all together. So 40y squared is my answer there. All right, what about this one with subtraction? Well, you're going to do the same thing. We notice that we have a p and a p. They're both the same term, so they can be added. The coefficients can be added together. Now, be careful, right? Because you have this minus and negative. Anytime you have that, what do we need to do? Good. I hope you're saying we need to change it to addition, because this is minus a negative is the same thing as saying we have 16p plus 7p. Because this is like negative times negative. This is like -1 times -1 almost. So you could think of it that way. But minus the negative is going to simply be saying the same thing as adding. What is 16 plus 7? Let's see, 23p. So that's 23p. All right, next problem. Simplify this here. So we're going to combine all our like terms. Let's identify those like terms. I see a c squared and I see a c squared. Well, what's the coefficient in front of each? Don't forget that there's a 1 in front of this. We don't write it in algebra typically. So just remember there's a 1 there, and I have a -6. I can't combine this d squared with anything, so I'm gonna leave that alone. So what is 1 minus 6? Well, it's going to be a -5c squared plus 7d squared. Now, it doesn't matter which order. According to the rule of commutative property of addition, you can put them in different orders. It doesn't matter because it's addition. 2 plus 3 is the same thing as 3 plus 2. However, you're commonly going to see this in alphabetical order. So for instance, this is c squared and that's d squared, and that's just kind of typical. So get used to that. And if you're wondering if there's a preference, then there you go. Keep it in alphabetical order. All right, what about this piece here? U squared times v plus 5u squared minus 3v squared. So what about our like terms here? Well, I look at my coefficients and I notice that this is u squared v. That's one term. U squared is a different term, and v squared is another term. There's actually nothing I can combine here. So that can be tricky, and it can be tempting, right? Because you see a u and a u here, and then you see a v and a v, and you want to put them together, but these are 3 different terms. It's like adding apples, oranges, and bananas. I can't say I got 3 apples, 2 oranges, 4 bananas. How many you got all together? You can't do that. You're going to have to change the term and say we have this many pieces of fruit. You're not going to be able to say apples, oranges, or bananas anymore. So we're not going to do that. We just have to leave that alone and leave it just like this. It's already simplified. So that one can be tricky, so watch out for those. All right, let's continue our practice with these. I encourage you to pause it and work it yourself on your paper before I work it. See if you're going to get this right. So I'm going to go through these kind of quick. All right, so let's start with this one. We're just adding, right? We got parentheses around these both, but we're adding, so these parentheses really aren't necessary because nothing's going to change with these signs. We're just adding them all together. I am going to, however, identify my like terms, y squared and y squared. I'm going to add 5 and 3 to give me 8y squared. So what I like to do is cross these out, because it helps me mentally see that I'm already completed that part, and it breaks down the problem a little bit easier. Now I see my next one's going to be my y, just y by itself. That gives me a -3 and a -4. Don't forget to include those negative signs because that's an important part of that number. You can't disconnect those. So you're going to have a -3 minus 4 and a -3 minus 4, or a -3 plus a -4, however you want to say it. It's still going to give you the same number, -7y. I'm going to cross those out. Now I'm left with 15 minus 11. That gives me a +4, and we're done. Just kind of look back through this, double check. 5 and 3, -7, 15, and that looks great. All right, so let's go to this one. So this you got to be careful with. Why? Because you have this negative or this minus sign preceding this parentheses. The reason you got to be careful is because a lot of students would subtract 2w squared but forget to subtract -4. And the subtraction is saying subtract everything in that parentheses. So I'm going to actually rewrite this whole thing to make sure you see what I'm talking about. And you might need to do the same. So this is going to be distributed. This negative here is going to be distributed to be -2w squared. And then it's going to distribute here to be a +4, because negative times negative is a positive. Now I can add my like terms, and I see that I have a w squared and a w squared. Well, now I can add those coefficients. 9 minus 2 is going to give me 7w squared. Like to cross those out, and I'm left with a w now. Do I have any other w's? Doesn't look like it, so I'm going to just do -7w. That's gone, and now I'm left with just a 5 and a 4. Adding those together gives me 9. I still circle my answer. I'm just so used to that, and most teachers like that, by the way, because you have all this work and it's easy to see. But I guess I really didn't have to. All right, let's continue this. Now, what if it's set up this way? C squared minus 4c plus 7 from this. Now, this is confusing a little bit because you're used to saying, let's take this and say minus the first one. But this one, you're going to have to reverse it because we're subtracting this portion away from this piece here. So I'm going to have to start with this. So I'm going to go ahead and rewrite it so that I can show you and show myself what it looks like, and I won't make a mistake here. 5c plus 3. And then I'm going to subtract all of this piece here. C squared minus 4c plus 7. All right, now that I've rewritten that, it's easy to see what I need to do. I need to make sure this negative gets distributed to all these things. Now, if you could have seen that without doing that, more power to you. Rewrite it, do what you have to do. I just want to make sure I write it out completely so you can see what's actually going on. So I'm going to rewrite all of this piece here, plus 3, and then I'm going to distribute my negative to every term in that parentheses. So this is going to be a minus c squared minus 4, I'm sorry, plus 4, right? Because that's negative times a negative, plus 4c, and then a minus 7. So when I put those together, what do I get? All right, first thing I'm going to do is identify my like terms, c squared and c squared. I know I can add those coefficients. What are my coefficients? 7 minus 1 gives me a 6 c squared. Cross those out. I'm done with that. And I have a c and a c, and that's -5 plus 4. That gives me a -1. So I'm just going to write negative c there. And then I have 3 minus 7. That leaves me with a -4. And there we go. All right, so now we're adding on this one, and I'm not even concerned about distributing anything, right? Because distributing a plus times 1 doesn't do anything. So I can just go straight to adding my like terms. So u squared and u squared. I have a 1 and a 3, so that gives me a 4 u squared. And what about UV? So I have a UV and a UV, so I can get -6 and 2. That gives me a -4 UV. And what about V squared? There's nothing to combine with that one, so we're done. Circle it. I love circling. All right, so next one. Find the difference here, and I encourage you, go ahead and work this one. It's just like we've done before. Before I work it. All right, so if I'm going to work this, it's p squared. I'm rewriting this, and I'm going to rewrite it. Why? Because I notice there's a negative here I need to distribute, and I want to make sure I don't make a mistake just trying to quickly do it in my head. So I'm going to say minus p squared minus 10pq, and then plus 2q squared. Why? Because negative times a negative gives me that positive. Negative times this positive gives me a negative, and negative times this positive gives me a negative. Now let's look to combine any like terms. Do I have any of the p squares? Let's see. I have a p squared. I have a p squared here. Do I have any of the p squared? So you might have to go do that each term, because sometimes when you have all these letters like this, it can look confusing. So I'm gonna go through one at a time and check. So 1 minus 1 actually goes away to nothing. So there's nothing else there. That completely cancels out. Let's start my q squared next. I have a q squared here and 1 here. This is a 1 plus 2. That gives me 3q squared. Done with that. And now I don't have any other thing. See how easy this is? Now I've crossed everything out to see that this is the only thing remaining. So that's a negative 10pq. And done with that. Star problems. So let's actually see, what does it look like on the star test. I'm going to take some questions from previous star tests, a couple of questions, and show you how you're tested with this skill. All right, question number 13. A couple of years ago, a shoe company is going to close one of its stores and combine all the inventory from both stores. These polynomials represent the inventory in each store. Which expression represents the combined inventory of the two stores? Now, careful that you understand and you caught that they're asking for the combined inventory. If you were to glance at this, being the astute algebra student you are, you may have thought before we got in there, after you've gone through the whole course and it's the end of the year, you may have thought this could be a system. And you may not know what a system is at this point. A system of equations, that's two equations, two linear equations for algebra 1. And you're wondering where they cross. That's what this could look like. But they're asking to combine these two. So we're not going to do that actually. We're going to just combine them like they said. So let's use the same skill that we did before and identify our like terms. So I have a g squared and a g squared. I know I can combine 3 and 1/2. Well, 3 and 1/2, if I combine 3 plus a half, 3 plus a half, 3 and a half is the same thing as 3 times 2 is 6 plus 1 is 7. It's 7 over 2. So it's going to equal 3.5 either way. So you can see that those are both the same thing. So 7 over 2 is what I'm after. Why? Because I can clearly see that they're using 7 over 2. So getting that first part didn't help me at all, because all the answer choices are the same. However, when I move a little bit further, let me go ahead and write that 7 over 2 g. I got that part. Now I have a g. Do I have any other g's I can combine with? All right, so I don't see any other g's. So I'm just going to use the one they have, negative 4g. Negative 4/5 g. 4/5 g. And I always like to glance, sometimes I do, like to glance at the answer choices because they did give them to me, the answer choices. There's only 4 possible. And now I know that this is right so far. All of them have 7 over 2 g squared, but what about negative 4/5? Well, negative 4/5, this is not right, and this is not right. So I'm already at 50% if I were to stop now. So that's pretty good feeling. And then I have 7 over 2 plus 1/4. 7 over 2, let's put that over here, 7 over 2 plus 1/4. Now, you may not want to do this math, and the great thing is you got a calculator. Just add it up in your calculator. But I'm going to go ahead and do this by hand because it's just quicker. I'm going to get a like denominator. So I need a 4 down here. So I'm going to multiply the top and bottom by 2. So that gives me 14 over 4, because 14 over 4 is the same as 7 over 2. Now I can add these together. 14 plus 1 is 15, and 4 is going to stay the same. So now I know that I'm supposed to be adding a 15 over 4. Let me make sure I'm adding. Yep, plus and plus. Yep, these are adding together. So this is actually what I'm looking for. So now I'm not even distracted by these two anymore. I don't care that this is 15 over 4. I already know that this can't be right. So now I'm just looking at these two, and it becomes obviously clear that A is the best choice there. So good job to you. Now I want you to try this one yourself. This is the last one before we close out here. And before I do it, would you have gotten this problem right? Pause it and see if you can work this on your paper. All right, so if I'm working this, I'm looking through it already, and I see a negative that can be distributed. That can trip some people up. I'm going to, just to be safe, go ahead and rewrite the whole problem and make sure I do that. I'm going to distribute that. Plus 9, and I'm going to distribute this negative like so. Distribute here, and there's going to be a negative 3. Now I can come back and add my like terms. So I got an x squared here, an x squared here, and nowhere else. That gives me 2 minus 6. 2 minus 6 is a negative 4x squared. That's gone, and that's gone. Yay, so I know it can be these two. See, sometimes just getting started with the first piece, and this can look like an intimidating problem for some people, but not for you, right? You're just going to take one little step at a time. So that eliminates half my choices. I can close my eyes and be at 50% and get this right, but we're not going to do that. But it's encouraging to know we could just by just getting it started. Now my next one is x. So my next variable, and notice I usually start with the highest exponent and I work my way down. You don't have to, but it's a good pattern to adopt. So I start with my x's now. I got a 4x and a minus 6x, and I combine those, I get a negative 2x. And those cross out. And I glance over here, they both have negative 2x, doesn't help me. And I have a 9 minus 3. 9 minus 3 gives me a 6. I almost forgot what that was. There we go, and there you go. Correct answer. Congrats to you if you got that right. It's that simple. We are at the close. Did we complete our objective? Yes, we added and subtracted polynomials of degree 1 and degree 2. Fantastic. And yes, we covered these items underneath here as well, talking about monomials, binomials, and trinomials. The best to you guys. Thanks for tuning in. I'm Brandon Clayton, the Algebra Guy. I'll see you next lesson.